Okay, so continuing on with 7-5, we're looking at, so in the first video, we did a review of radicals, and in this video, we're going to talk about how radicals and exponents are related to each other. So we're going to be switching things between from exponent form into radical form. So we're going to take the exponents and we're going to make them radicals, and I'm going to talk through that. So basically how this works is the numerator. So I'm just going to do an example that's not one of these. These are the ones from the worksheet, but I'm just going to do a quick example here. If I have x to, say, the 2/5, the numerator is going to stay as an exponent, but the denominator is going to become the index of a radical. So if I have a radical like this, the index is the number that goes here. So the denominator is going to become the index. The denominator is going to come down here, and then the numerator is going to stay as an exponent. So that's how this works. The numerator stays an exponent. The denominator becomes the index of the radical. So it goes in front of the radical like this. So this is the 5th root of x squared is how you would say that. The 5th root of x squared. So let's actually go ahead and do the examples with that in mind. So for this first example, the number out front, the exponent, it's kind of hard to tell because it's hard to write small, but this 3/4 is the exponent of this x. It doesn't apply to the 15. So the 15 is just going to sit out in front. It's not really going to do anything. Then the denominator, again, the denominator is going to become the index. So this denominator, the 4, is going to go here. It becomes the index. And then the numerator stays as the power. So if you're asked to rewrite in radical form, this is what you're looking for. You want the denominator becomes your index and the numerator stays as the power. So this would be the answer to number 10. So let's do that with number 12. So again, a 16 doesn't have an exponent applied to it, so it's just going to stay out in front. The denominator here is 5. So that's going to come down here. T to the first power. We don't have to write things to the first power. So the simplest form of the answer would look like this, which is 16 5th root of t. So if you see something, a power that is a fraction with a 1 in the numerator, you can think of that 1 over something is that root. So this would be a 5th root. So 1 over 5 is the same thing as a 5th root. 1 over 3 is the same thing as a cube root, or like this, right? So a power of 1 over 3 is the same thing as a cube root. Power of 1 over 2 is the same thing as a square root. So with that in mind, let's look at number 8. So with number 8, we have the 1/2 outside of a parentheses, which means that before we turn it into a root, we need to distribute it. So we want to distribute it first. So remember that 25 has an invisible power of 1, so we're multiplying 1 times 1/2, which is just 1/2. And then x 2 times 1/2 is just 1. 2 times 1/2 is 1, so we have x to the first. So now if we change this 1/2 to a root, we're going to have 25 square root. So if it's a square root, if the index is 2, we just leave that as an invisible 2, because that's what a square root, well, the square root we're used to seeing always has an invisible index of 2. So 1/2 is a square root. So we have a square root of 25 times x. We don't need to write the first power. So we have square root of 25x, And then the square root of 25, hopefully we all know that's 5, because 5 times 5 is 25. So the final answer here would be 5x. So the point here is when we're rearranging exponents as radicals, we just take the denominator of the exponent, and that becomes the index of the radical, the thing that goes in front. It's called the index. So that's what we're going to be doing on all of these. That's what it means when it says change it from an exponential to radical form. Okay. Let me know if you have any questions, and I'll see you in the next video.